Hello everyone. We are going to study basic probability. Now, in everyday life, we make decisions and we are uncertain about that outcome. The decisions could be, should we invest the money in the stock market? Should we get extra collision insurance on the car? Or should we start a new business? In each of these simple examples, we are uncertain about the outcome. So let's look at the stock market. Now, if we invest the money, we do not know if our money is going to grow or it's going to remain the same, or we're going to lose the money there. Or if we start a new business, how successful we are going to be in that business. So in these scenarios, we are very uncertain about the outcome. In order to study this uncertainty about these outcomes, we will look into probability. Let's start with a very simple example as flipping a fair coin. Now, when we flip a fair coin, we do not know whether we're going to get a head or a tail. So every time we flip, getting a head is uncertain. Now, to study this uncertainty, we're going to look into the probability theory. We will learn how to measure the outcomes of a random phenomena for which they are uncertain. Let's look at some types of probabilities. There are three different kinds of probabilities. One is the subjective probability, experimental probability, or theoretical probabilities. Now, in subjective probabilities, it's it's a chance whether I'll pass the course with probability 80% or can finish my homework on time is 50%. They're all very personal, they're very subjective. Experimental is like, all of us have played this game, rock, paper, and scissors. So when we play this game, we do not know whether we're going to, who's going to be the winner in this game. So in this game, suppose Sally won 25 times out of 71. It's an experimental probability. And in this one, she wins the game, say 25 by 71. And how it is counted is by the number of observations of an event divided by the total number of trials. Then the other one is theoretical probability. They are based upon reasoning. So if you apply the rock, paper, scissors in terms of Sally winning the game is 1/3. Now, for us, we will be focusing more on theoretical probabilities. I will start with some terminology. So let's look at them. First, we're going to talk about an experiment. An experiment is an action whose outcome cannot be predicted with certainty. And these experiments will result in some outcome. So remember, we talked about this flipping a coin. Now, when we flip a fair coin, there are only two possible scenarios. Either we get a head or we get a tail. So when we collect all possible outcomes in an experiment, we call that a sample space. So when we write it down for the flipping a fair coin, the sample space would be a head or a tail. And we usually denote this sample space by capital S. And we can represent these sample spaces as listing all possible outcomes or creating a tree diagram or creating a Venn diagram. We'll look at all of these later on. Continuing with our terminology, let's talk about an event. Now, an event is the result of an experiment. It is a subset of the sample space. It's a collection of outcomes from the sample space. And we use uppercase letters like A, B, E to represent events. And we have kind of, reserved the capital S for sample space. Now, remember we talked about Venn diagrams. Venn diagrams are nothing but graphical descriptions of events in a sample space. So let's say if we have a sample space, the head and tail. So the sample space in a Venn diagram is represented by the whole square, and every possible outcome is basically inside it. So this square, guys, is my sample space, this little square we have. Now, if we collect a bunch of these events, these events here. So we collect them together. So if you're looking at these events, that becomes, some of our possible outcomes, that becomes an event. If you look at every possible outcome in a sample space, they will be shown over here on this little graph. So let's talk about how do we define a basic probability. So let's look at that. Now, if you're conducting an experiment, the first thing we assume is that every possible outcome is equally likely to happen. And let E, the capital E, is an event, which is a subset of these set of outcomes, and F represents the number of outcomes which result or are favorable to the event E. So the probability of an event E is denoted by capital P, and we put in parentheses the event E. It is defined as the number of ways that elements can happen in the event, which we denote by F, divided by the total number possible of outcomes. And one of the most important things is that the probability of any event is always a real number, and it lies in the interval 0 to 1. So let's go back to our flipping a fair coin example again. So when we flip a fair coin, we know the sample space is either a head or a tail. So let's look at an event that a head shows up when a coin is flipped once. So when you're flipping a coin once, there are only two possibilities. The event is we're looking at the head. So what is the probability of an event? Head only shows up 1. So 1 divided by the total number of outcomes, which is head or a tail, which is 2. So the probability of an event which shows up is a half. Now some observations about probability. Now the closer a probability of an event is to 1, the more likely the event is to occur. So let's look at a simple example. When you look at black, with clouds, and if they're very, very dark, and we say, oh, there's definitely a possibility of a rain coming. So that's like probability of an event very, very close to 1, because we know it might happen. Now the closer of a probability of event is 0, the less likely the event is to occur. Now it's very shiny, it's very bright, shiny, sun is there. And then we say the probability of a rain happening, very, very 0. So that is like, that event may or may not happen. So when we say the probability of an event that definitely must occur is a 1, probability of an event that cannot occur is 0. But events with probability, definitely happen. With probability 0, happen all the time. So let's go back to our simple examples and find out how to figure out probabilities. We go back to, let's look at a simple die. So when I roll one fair and it's a red die, what is the sample space? So in one die, we see there are 6 faces, and each face has the number either 1, 2, 3, 4, 5, 6. For the sample space, it is 1, 2, 3, 4, 5, 6. Now let's look at the probability of an event. My event is that the die shows a 4. When you look at these 6 events, there's only one way 4 can show up when you throw or roll a die. So what is the probability here? It is 1 divided by 6. Now let's look at the probability that the die shows an even number. So when we go back to the sample space, how many even numbers are there? It's 2, 4, and 6. So there are 3 possible elements or outcomes in my event E over here, that the die shows an even number. So the favorable outcomes are 3, the total number of outcomes is 6, and the final answer is a half. Now let's look at the probability that the number on the dice exceeds 7. Can ever 7 show up? It's never a possibility. So this one is a simple 0. Let's look at one more example. Now here we are going to throw two dices, a white die and a green die. Now how many possible outcomes are going to be there in this sample space? There are 36 of them. Every time you're rolling two dice together. So the first die, if it is 1, there are 6 possibilities for the green die. So in total there are 6 events. Then suppose if the white die shows a 2, then there are 6 possible scenarios for the green die. Similarly, for the other 4 scenarios, when the white die is a 3, white die is a 4, and 5 and a 6. So in total there are 36 possible outcomes when 2 dice, a white and a green die, is thrown. So let's start with the probability that the white die shows a 6. Now when a white die shows a 6, we are looking at this scenario. The white die shows a 6. There are 6 possible scenarios. So what do we get? The probability is 6 out of 36, which is 1 over 6. Now, the probability that the sum is 11. Now let's look at the sum to be 11. So how many ways can you have a sum to be 11? We can have a 5 and a 6, a 6 and a 5, or we can have 7 and 4. But remember, the number 7 never shows up. So what is the sum is 11? So if the sum is 11, let's look at this one. If the sum is 11, what are the possible outcomes? Either it can be a 5 and a 6 or a 6 and a 5. So looking at this one, a 5 and a 6 is this, or a 6 and a 5 is this. So there are only 2 possible ways when the sum is 11. So when you write this one down, you have what? 2 out of 36. We can take the common factor 2 out. You get 1 over. So you have what? 1 over 18. Now let's look at the doubles. The probability of a double showing up. Doubles means both the white and the green should have the same number. Okay, so when we go for that one, so let's look at the doubles here. How many possible values? We have 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. So the probability of doubles, there are 6 possible favorable events. Once again, it is 6 over 36. The answer is 1 over 6. Now let's look at the sum of a dice exceeds 12. Now, if we have the highest number on the dices, it's a 6 and a 6. So basically, the maximum value of the sum can be 12. But here the question is sum of dice exceeds 12. That means it's never going to happen. So what's the probability for this kind of an event? It is 0 over 36, or the answer is 0. Thank you.